So members, today we are still seeing applications of differentiation. Now, in this question, we are seeing a rectangular box is to be made out of a rectangular sheet of size this by cutting out squares of x centimeters from each corner, so that the volume of the box form is this. Now, this is the number. So that now our rectangular sheet, you see that we have cut out all the sides. An example is here. If I have this as my rectangular sheet, that is rectangular. Now we are cutting out these edges of x square meter. So if I get my scissor and I cut out these ones here, so that I will be cutting them out properly. So now, if I cut them out, you see that I'll be removing now these squares. So I remove this square, I also remove this square, I remove also this square out on the edges. So also I remove this. So that what I'm remaining with is what I have there. So this is what I'm remaining with. Now, I'm to form a box from there. So now if I put these sides up like this, you see that I'll be having a certain box form from here. So if I push these sides up, this is the box I'm making. So it's that we are making a box. So we want to make it out of this rectangular sheet. So if I have now, if the length here I said it was 8 centimeters, but if I remove x, because the square will remove it had of side x, because this is x and this is x. So if I remove now x from here and remove x from here, the remaining length here is going to be now, because the total was 8. So it was 8, but now I'm removing x and I'm removing x and I'm removing minus 2x. These ones. So this one was x and here I remove x and here I remove x. I mean that because this was 5, so if I get 5 minus this x and also this x, there will be 2x. That's what I'm adding. So that's now the length I've been remaining with and the width I've been remaining with. Now, if you see that I want to form a box, but if you see the box I'm going to form, this is the type of the box I'm going to form. But its volume, the one I'm going to make is volume. I know that orange, the volume of the box is given by length times width times height. So here my volume will be, now my length is 8 minus 2x times the width, which is 5 minus 2x, now times the height. The question is how I will get the height. Now, when you look at this box, you see that if this is x and this is x, when I push it up here like this to form a box, so that this length here is going to be forming the height. So the height is going to be the length of this square that was removed. So my height now is going to be the length of this square, but this square was the length x. So this will be our height. So from there, we can easily multiply and we see. So here my volume will be this times this. I'll be having 40. Then this 8 times this, I'll be having minus this and this. I'll be having minus 16x. Then minus 10x. I mean minus 10x, which will give me negative 26x. Then this and this again, plus 4x squared into x. Opening brackets, so that this x will be 40x minus 26x squared, then plus 4x cubed. And it's now, this is the formula, the one that's approved. So that's the volume of this box. Now I want us to find the maximum value, I mean the maximum volume. So the maximum volume, of course, we have to differentiate first of all. So we know that the differentiate will just now x divided x will be, now this will be 40 minus, if I multiply this, I'll be having now, so that I'll be having 52x, then plus, when I multiply here, I'll be having 12x squared. So that now, we say that at maximum volume, at maximum, we know that always our limit, the x will be always at 0. So equating this to 0, we'll be having now 12x squared minus 52x, then plus a 40 equaling to 0. Why? Because the maximum volume always the derivative or the be 0. To start here, you can divide it through by 4. Divide here by 4, you have 3x squared. By 4 here, you have 13x. By 4 here, you have a 10 equal to 0. And so you can factorize this as 3x minus 10 into x minus 1 equal to 0. So, therefore, either your height is 10 over 3 or your height is 1. So now we need to know which of these ones is going to give us the maximum. Now there we shall use the second derivative test. Now if we get the second derivative of this, it's like the second derivative of this will be now v squared, x squared will be, this will be 0, so this will be negative 52. If I do show this again, then plus, this will be now 24x. Now, I start substituting the values of x at the maximum. So when x is 1, so when I put in 1 here, I'll be having a negative. So you see that when I put in here maximum, I'll be having a negative as the overall answer when x is equaling to 1. So that my second derivative, the x squared, is equaling to negative 28. So when I put in x equaling to, to 10 over 3, you see that now the overall volume in the second derivative will be a positive. Now, because you say that to have a maximum, your second derivative should be less than 0. So it's that this one is giving us a negative. And the negative is that if we have a negative here, it means that this one is going to be our maximum value of x. So therefore, the value of x is going to give us a maximum is 1. This one is giving us a positive, and so it will be giving us the minimum, yet we want the maximum. So the value of x I'm going to use is this, using the second derivative test. So if you know now x is going to give me, that one is going to give me the maximum, now I come and substitute my volume. From my volume equaling to 40x minus 26x squared plus 4x cubed. Now I put in this, it will be now 40 into 1 minus 26 into 1 squared and plus 4 into 1. So that now my volume will be 40 plus this is 40 plus 4, that's 44 minus 26, that will be I think 18 centimeters cubed. So now that will be the volume, and it is occurring when the height is 1. If the height is 1, we calculate the length and we calculate the width. So that's how we start. Members, I wish you the best. Don't forget to subscribe to the channel.